Okay, so for question 6, question 1 is obviously a definition question again. Write down the meaning of a reversible reaction. It's a reaction where products can be converted back into reactants and vice versa. Then they want you to state Le Chatelier's principle. This is a terrible definition. We hate marking it in the finals, but anyway, there's a whole lot of versions that they'll accept. So there's the definition of Le Chatelier's principle. When the equilibrium in a closed system, so remember we spoke about it with the physics. Physics systems are isolated, chemical systems are closed. So when you have equilibrium, it must be a closed system. You're not adding anything to it, and nothing is getting removed from it. In physics, it was isolated. There were no external forces. So when the equilibrium in a closed system is disturbed, in chemistry, the system will reinstate a new equilibrium by favoring the reaction that will cancel the disturbance. 6.3, I haven't even looked at this graph now, but anyway, okay, so now, take note, the volume of the container is 4, we're going to use that maybe for our Kc calculation, and it says it's 150 degrees Celsius, and then here is the reaction. Just check quickly, all 3 of these things are gases, so we don't need to worry about solids. Then, in this graph, they say that a change was made to the equilibrium mixture at 80 seconds. So that's here. Basically, whatever this is, went straight up. This one here, they increased the number of moles of A2. A2 was increased. So they say write down the change. So you should just say the amount or concentration or number of moles of A2 was increased, or A2 was added to the container. And they say use Le Chatelier's principle to explain how the system would react. So if you increase the amount of A, the reaction will try and decrease it by favoring the reverse reaction. So if you increase A2, the reaction will try and decrease A2 by favoring the reverse reaction. So for 2 marks, you need to say that the reverse reaction was favored, and because A2 increased, they want to decrease the amount of A2. You can talk about it in terms of products and reactants as well. So if you say the amount of products increased, so therefore you want to increase the amount of reactants, so you favor the reverse reaction. Then for 6.4, they say calculate the equilibrium constant. We have been given the number of moles at equilibrium. So this might be confusing, but it's actually a bit easier. We have been given the number of moles at equilibrium. So this is the Kc statement. The Kc statement is A2, B2 at the top. So the products are at the top. It's products over reactants always. And the reactants have a square because there's a 2 in front of the reactants. And so this is the Kc statement. This number here for AB, it's 12, and the concentration, it will be, when are we supposed to do it? At 120. Oh, I'm so sorry. We're doing it at 120, so we're doing it here. So the amount of AB at 120 seconds is 10. We're dividing it by 4 because that's the volume. So it's 10 over 4 squared at the bottom. It's 8 over 4 for A2, and it's 2 over 4 for B2. So you put all those numbers in, just smash them into your calculator, and you get 0.16. So basically that, because it's less than 1, it means that the reverse reaction is being favored. The reverse reaction is happening more than the forward reaction. Then they say at 6.5, the temperature of the system was decreased to 100 degrees Celsius. So this is why we made a note of this at the beginning. It was 150, it's now 100. So they say draw a potential energy diagram for this reaction. That is pretty much a question 5 question, not a question 6 question, but we are still going to be able to do it. So we are a little bit stressed now because we haven't seen a question like this before. I do know what to do because, anyway, it doesn't matter. So at time 1:30, so that is over here. At time 1:30, they say that the temperature was decreased they decreased the temperature. And what happened is AB increased. So they decreased the temperature and the amount of reactants increased, which means the reverse reaction was favored. The reverse reaction was favored. If you can't understand that, this one went down here, this one went down, this one went down, this one went down, this one went up, this one went up. What happened here was the reverse reaction was favored, and the same thing is happening here. The A2 and the B2 are going down, the amounts are decreasing, and the AB is going up because the reverse reaction is favored. I am decreasing the temperature, the reverse reaction is being favored. Decreasing the temperature always favors the exothermic, always, because the exothermic is making heat. So decreasing the temperature favors the exothermic. In this specific case, the reverse reaction was favored, so that means that the reverse reaction is exo, which means the forward reaction is endo. You need to draw an endothermic graph, which is what they've drawn there. That is an endothermic graph because the forward reaction is endothermic, because when I decrease the temperature, decreasing the temperature favors the exo, and the reverse reaction was favored. That means that the reverse reaction is exothermic, which means the forward is endothermic. So they're asking you in a very roundabout way to draw an exothermic energy graph, which you did quite a lot in grade 11, and we did do when we did reaction rates in grade 12. Then they say, will the equilibrium constant be greater than, less than, or equal to Kc at 150? So the Kc at 100, the Kc at 150 is the one that we calculated and was 0.16. When we decrease the temperature, we favored the reverse reaction, and that means that the Kc value will decrease. If you favor the reverse reaction, you will have less products and the Kc value will decrease. The Kc value will only ever change if you change the temperature. We lowered the temperature, we favored the reverse reaction because the reverse reaction is exothermic, which means the Kc value will decrease. Okay, so here they say it's going to be less than because the amount of products decreases. The reverse reaction is favored. So we said all of those things. Then for 3.6, the initial reaction now takes place in the presence of a catalyst. So the reaction that happened in the beginning is now happening with a catalyst. It always happened at 150 degrees, that is not a change, but now we have a catalyst. Describe the changes between t equals 0 and t equals 60. What is going to happen to that part of the graph? Basically, it's going to be much steeper. The graph will be steeper because the reaction is happening faster. It will get to the same horizontals. It'll just do it much faster. If you add a catalyst, you just get to where you want to be much faster. Oh, sherbet, sorry. So you get to the same height, but you just do it much sooner. The gradient is an indication of the rate because it's divided by time. So the graphs they would get to the same point, the amounts wouldn't change, but the gradients would be much steeper and they would get horizontal sooner.